All right. Thank you very much, Jerry. Josh, well done on the weather report. We're going to go ahead and do a hard gear shift here. Like Jerry mentioned, we're going to start zooming in, talking about cover crops. So whether we can believe it or not, it is early to mid-July already. And that means that in the next 4 to 6 weeks, we'll have a fair bit of small grain acres being harvested, processing crops being harvested. And so kind of our first big kind of post-harvest cover crop establishment window of the year. And so we thought this would be a really good time to plug in a cover crop talk, and specifically a clover, or maybe more broadly legume cover crop talk, as summertime is a really good opportunity to get them established. So as I've titled the presentation today with a question: can clover cover crops provide meaningful nitrogen credits to corn? We're going to spend some time on this path to an answer to that question. And so to get started, we'll kind of just highlight, overview what is a nitrogen credit, how do we get one, and really importantly, why do we care about this concept of nitrogen credits? We'll also kind of highlight specifically how cover crops tie into this nitrogen credit topic. We typically don't think of cover crops first when we think nitrogen credits, but we'll tie that in. We will also look specifically at a project that wrapped up last fall, and then we'll highlight some other data in the state that can really give us some information on nitrogen credits from different legume cover crop species. And we'll kind of put a bow on everything with some practical takeaways, both from the research we'll talk about today, as well as some other existing information available to you. So a very basic definition of a nitrogen credit: it is the amount of nitrogen, or N, that is provided to the current cash crop by a previous organic nitrogen source. All right. And so it wouldn't be a good nitrogen talk without spending the next hour, I think Jerry told me I have, on the nitrogen cycle. Just kidding. We're going to zoom in on some of the below ground aspects just for a few minutes of the nitrogen cycle when we're thinking about nitrogen credits and what they are and how we get them. So typically when we're thinking about nitrogen credits, we're really focused on generally manure. So we've applied some manure. How much nitrogen do we think we'll get out of that manure application for my next crop? We also think about this quite a bit in forage legume scenarios, such as alfalfa or a stand of clover, something that's been out there for 2, 3 years, so on. And so why legumes? Why do we talk about N credits in the legume space, whether that's forage stands or cover crop stands? So legumes do this really cool thing where they form symbiotic relationships with soil rhizobia that fix atmospheric nitrogen and then assimilate that nitrogen into the plant biomass. And so then when that plant biomass is terminated via chemical termination, tillage, incorporation, etc., that crop has a relatively low carbon to nitrogen ratio. And so what that means is that as this underground nitrogen cycle starts to happen, as our soil microbial communities start to break down that biomass, the nitrogen that's in that biomass is readily available, generally speaking, to the next crop. It doesn't get tied up in that breakdown process like it might if those microbial communities are trying to break down something like oat straw or corn stover, stuff with a lot more carbon relative to nitrogen. And so again, we're kind of zooming in on manure and legumes. The big problem right off the bat, though, right, if we're thinking about next year's corn crop following these organic sources of nitrogen, is that organic N is not plant available. So we need those microbial communities to break down these materials and convert that organic nitrogen into the plant available forms like ammonium and nitrate. In addition to needing those microbial processes to occur underground, we also need them to occur kind of in a timely manner, right? So we need that biomass or that manure, whatever that organic source is, to be decomposed in that nitrogen conversion process. to be complete before, say, next year's corn starts to take up nitrogen rapidly. But we also don't want it to occur too early. We don't want that nitrogen to be sitting in the soil profile as nitrate too early relative to corn crop end demand, because then we're more susceptible for that N that was made available to be lost via leaching or denitrification or immobilization and other ways. So really just wanting to highlight what kind of needs to happen to these previous manures or previous legumes to get that nitrogen available. And so again, back to nitrogen credits here, why do we care so much? All right. And so the whole point of talking about nitrogen credits is that we take the credit. We call it taking the nitrogen credit. And so by accounting for this credit, subtracting it off of our base fertilizer rates that we intend on applying, it results in reduced end fertilizer application rates that we need to use fertilizer for, which is an economic benefit to us. Taking these credits can improve fertilizer end use efficiency of what we do apply, and it ultimately reduces our negative impacts on water quality. All right, so that's kind of where the credits come from. This is kind of why we care. Now we're going to zoom in and we're going to spend a fair bit of time on this the rest of the day today, how we calculate these credits. All right, so this is likely familiar to most folks, but we're going to set the stage up with a classical end response figure here. So on your horizontal axis, you'll see nitrogen fertilizer application rate in pounds per acre. In this example, we have nitrogen rate going from 0 to 250 pounds per acre. And then on the vertical axis, you have corn yield in bushels per acre. And so we see corn yield increases as N rate increases up to a point, corn yield flattens off. Okay. So in this nitrogen credit discussion, we can use this yield response information to help us calculate the credit. So again, in this example, you have two different colored lines. The black line is representing corn yield response to nitrogen fertilizer rate when that corn did not follow a previous legume. And the red is corn yield response to nitrogen fertilizer when corn did follow a previous legume. Okay, and so you can see visually there's something different about these two environments, these two yield responses. And so if we can apply some statistics and determine a few characteristics of each of these curves, that can help us calculate, well, what was the credit from the legume in this example? And so the way that we're talking about nitrogen credits and how we're calculating them, we're using what's called the difference method. And it's the difference between what you're thinking. It's the difference in the economic optimum nitrogen rate, or the EONR, between the corn following no legume and the corn following the legume. Okay, and that EONR is the rate where economic return to the applied fertilizer is maximized. So here in this concept, EONR is where ROI from that nitrogen application was maximized. All right, so in this example, corn following no legume, the EONR was 150 pounds per acre. Corn following the legume was 125 pounds per acre. So using the difference method, our nitrogen credit is 25 pounds per acre. And so zoom back out. Now we know how to define and calculate a credit. How do we do this? So what? How do we use this? So again, I hinted at it before earlier on this slide, but again, if in this environment, in this example, let's say that our normal business as usual nitrogen application rate that we plan to apply is 150 pounds of N per acre, corn following, in this case, winter wheats, a small grain. If we have information, be that through on-farm research or through university guidelines or other experiences, and we have an idea of what that credit might be, we should take that credit and subtract that credit off of that base rate. So in this case, 150 was our base recommendation. If we had a good hunch that we were going to get 25 pounds of N, we would have subtracted that from 150 and applied 125 pounds of N to the field, right? So taking the credit is a big deal. So speaking of some information that is available to you currently, in 82809, our state fertility guidelines, we have this table. It's table 5.5 in the kind of what we call the new 82809 version online. It's table 9.5, I believe, from the 2012 version of 82809. But this table, this is about nitrogen credits from green manures. And so you'll see you've got different legume crops. You have alfalfa in there, red clover, sweet clover, crimson, and vetch. Um, the idea here is that these legumes were planted the season before corn, um, and then terminated and incorporated before corn was planted. And so current guidelines based on research suggest that if these legumes had less than 6 inches of growth at the time of termination or incorporation, you would take a 40-pound credit. If you had more than 6 inches of growth, you'll see a range, and the numbers in that range are higher than that 40-pound base credit, generally speaking. And so there's some other nuance that you can certainly read about in 82809 on which end of the range to use. But there's one clover missing from this table that we've been working on in the background over the past few years, and that's where we're going to segue to now. Okay, so again, we've talked about what a credit is, where it comes from, how to calculate it, some existing information. We're going to add some new information that's available to y'all. So, Berseem clover. This is the unveiling here of some Berseem clover work that's been going on. Typically, doing this nitrogen credit work in the cover crop world, we're targeting fields with a small grain crop ahead of corn. So oats, winter wheat, rye for grain, processing crops you could throw in here. Really what we're after is that earlier cover crop planting window. So we can get these clovers pounded in the ground as early as possible so we can put on good biomass. All right. So we're not going to spend a ton of time on, all of the goals of all different cover crops, but when we think about these legume cover crops, some of the goals that we're after in using them, late summer through late fall ground cover, living roots. So we're getting some of those soil health and soil conservation benefits throughout the fall. A lot of them will winter kill. Some of them may overwinter. Generally, we're looking at fall soil health benefits. But really, one of the primary goals is what you'll hear called growing our own nitrogen. Right, we're after these nitrogen credits, so it's all about pumping biomass before that winter kill and dormancy period. So, going into this Berseem clover research that we're going to step into here in just a minute, two primary questions that we set off to answer. Number one, how much nitrogen can Berseem clover provide to corn? And number two, does Berseem clover cover crops affect corn yield for the better or for the worse? Okay, so let's go ahead and dive in here. So this is some work that was done in northeastern Wisconsin. Hat tip right off the bat to Kevin Jarek and Scott Royce. They are our local regional crops and soils educators up in this region. They sought the farmers and the crop consultants that were curious and asking similar questions. They did most of the field work, data collection, so on and so forth. So huge thank you to them. Shout out to Dan Marzu for extra field help in the field. And then thank you, Dr. Matt Ruark, for helping support this project with some funding and a harvest crew. Obviously, huge shout out to our host farms for letting us bother you for a year and a half. So what do we do here? So the timeline of a project like this, we're starting off, in this case, about August 15th through September 5th, just depending on the farm. Again, there's 5 farms represented here, is when we established the cover crop. So in each field, we had strips of Berseem clover, and then we managed and maintained strips of just winter wheat stubble and winter wheat regrowth. So you have strips of both. Fast forward to November of 2024, right before that killing frost. It was about a week before the gun deer season. Scott and Kevin went out and collected the above ground Berseem clover cover crop biomass samples so we could understand how much biomass did we get out there. Fast forward to spring 2025, all the Berseem clover winter killed, generally have a mat of dead Berseem clover on the ground. Corn was planted across the entire field. So again, corn was planted in the no cover crop strips and in the Berseem clover cover crop strips. Fast forward about another month, we get to June, and we then implemented our nitrogen rate study over the top of those cover crop treatments. And so we ended up, pardon me, we ended up applying 6 different rates of N, 0 to 250 pounds of nitrogen. And so now what we've set up is the ability to have corn grain yield response to nitrogen fertilizer when corn followed both the Berseem clover and no cover crop. So you have that comparison to determine the credit. And then, of course, we hurry up and wait patiently, or maybe not, till fall to harvest the grain. So here's just an example of what one of these fields looks like, kind of the study design. Those green strips are your Berseem clover. There's 4 of them typically on most of the farms. And then that yellow, brown, orange color, whatever that is to you, that's your no cover crop strip. So just an example of what this looks like out in the field. Okay, so what did we find? With Berseem biomass, Berseem clover biomass, so again, we planted these mid-August to early September, harvested, and then subsequently winter killed mid-November. We had a wide range in biomass across the 5 farms. We have one location on the left. It's hard to see, but there's a deer hoof in the picture. We have very little biomass accumulation at this site at the time of sampling. Turns out deer love clover, so if you're a food plot enthusiast, by all means, Berseem is for you. But then we had 2 locations here where we called moderate biomass, so about 1,000 pounds plus or minus 100 pounds. And then we had 2 sites that had tons of Berseem clover biomass. So the one on the left, just shy of 2 ton, the one on the right, just over 2 ton of dry matter out there. So wide range in observation. Some takeaways from, we tried to look at, okay, it's only 5 farms, it's only 1 year. We had some other information at our fingertips, some soil test information. Tried to look at, was there any trends that helped explain why, 1 location had almost none and 2 locations had a lot. What was pretty evident in this small observational data set here is that soil test potassium and soil pH were highly correlated to Berseem clover biomass. So generally speaking, when soil test K was over 120 part per million, so kind of right in that optimum range or higher, and when soil pH was managed above 6.3, we saw the higher biomass production. So kind of makes sense. We know that when we're growing alfalfa or forage clover stands, we know that potassium and pH are both important. Interesting to see that translate into this cover crop setting where we're just going for a couple months of growth. So site selection matters. Planting date also matters. This was kind of just zooming out from this study in and of itself, but just generally speaking, I think we get a little bit lackadaisical when we talk about cover crop establishment after small grains, because it's like, hey, we got all fall in front of us to get these cover crops out there, no hurry whatsoever. And in reality, if we're using these clovers, these legume species, they take some time to get out of the ground and get going. So we should be chasing that combine or that harvest crew out of the field with the drill. So planting date certainly matters. And spoiler alert, more biomass means more higher nitrogen credits. All right, so we'll get there in just a second. Big picture, again, looking across all 5 farms in this study, Berseem clover cover crops did not affect corn grain yield. So you'll see the gray bar is the average corn grain yield where we had no previous cover crop, and the red is the average yield across all 5 farms following Berseem clover cover crops. 2 bushel difference, they're essentially the same number. At the individual farm level, again, across all nitrogen rates, just with and without cover crop is the only comparison happening here. No differences in corn yield at all. A couple numerical differences, but nothing popping out as being practically different. What I'll mention is that at the 0 nitrogen rates, I don't have the figure for this, but at the 0 nitrogen rates, at 3 of the 5 locations, we saw corn yield being statistically higher following Berseem clover than the no cover crop. The idea there is that in those low nitrogen supply environments, the nitrogen coming out of that Berseem clover is turning into yield. But not at every farm, just at 3 of the 5 farms that we see that. Okay. So what was the nitrogen credit? So looking at this figure, it's set up very similar to the example I showed a few minutes back. Berseem clover did affect corn yield response, and we did see an average credit, or we saw a credit across all 5 sites averaged together here. So gray is the average corn yield response following no cover. Red is that following Berseem. And now to get into what the credit was, we're going to pick apart these curves a little bit. Just interestingly, if we look at what we call the AONR, or the agronomic optimum nitrogen rate, this is the rate that maximizes corn yield. Following no cover crop, we needed about 233 units of N. Following Berseem, we only needed 179. That's usually, if my math is right, a 54-pound difference. And we got the same yield. All right, so that's interesting. If we were shooting for max yield, I'm really more interested in maximizing ROI. So looking at EONR, you can see that we had an average 32-pound nitrogen credit when corn followed Berseem clover. Okay, so on the average 32 pounds. However, I did mention that biomass matters. So really quickly, at that low biomass site where we had 160 pounds of dry matter, we did not see a nitrogen credit. Okay, those optimum nitrogen rates between the cover crop treatments were right on top of each other, so no credit there. At this moderate biomass site, about just shy of a half a ton, we see a 46-pound nitrogen credit show up there. I'll note that at the other moderate biomass site where we had exactly a half a ton, the end credit was 51 pounds per acre, so pretty consistent observation there. And then when we get to these really high biomass stands, right? So this is the example of the 1.8 ton per acre. We see something interesting. So again, looking at corn following no Berseem, that gray line, we needed 90 pounds of N to maximize ROI, that 90-pound EONR there. That red line is flat. So that means that corn yield was not responsive to nitrogen fertilizer when the corn followed Berseem clover. Okay, so all of the N that corn needed was supplied by the breakdown of that Berseem clover biomass and other soil supplied nitrogen. Okay, so and then the other high biomass that we had, it looked very similar. The credit was 100 pounds. So the corn following no cover was 100. Corn following that 2.1 ton stand was 0. So 100-pound credit from there. So key takeaways here: Berseem clover doesn't appear to be affecting grain yield up in the Northeast. You have a stand, but it's less than a half a ton. Generally, we're seeing 20 to 50-pound end credits. When you have huge stands, credits are much higher. So everything, it's all about biomass. Okay, so that's kind of the overview of this Northeastern study that we just wrapped up. Really quickly, Matt Ruark and others about 10 years ago worked up a very similar study looking at end credits from Berseem clover cover crops down in Sheboygan County. They found that end credit was typically between 15 and 40 pounds per acre, so kind of right in with what we observed. The big difference down there is they saw a pretty consistent 13 to 15 bushel increase when corn followed the Berseem cover crop compared to no cover crop, just the winter wheat as the previous crop. Down in the southwest part of the state, this little bit older information that Matt Ruark and Jim Studi summarized, they found average end credits to be about 20 pounds per acre, with a minor yield increase as well. All right. So when we take the Northeast study that we went in depth on, the work Matt Ruark did 10 years ago, and that other Jim Studi and Matt Ruark effort, we put all those on one slide here. So there's 9 different observations that we have in total with Berseem clover cover crops. The average is 42 pounds per acre. Okay. Obviously, again, biomass growth matters. So to kind of put a bow on this here today, key takeaways for your planning over the next 4 to 6 weeks if you're looking to pound a legume cover or a clover cover crop in the ground here, they can provide meaningful nitrogen credits. It's all about that biomass. And this comment here, incorporation not required, I'll say that maybe the assumption with those green manure credits that we looked at before is that those previous clovers or vetch were plowed under ahead of the corn planting. In our northeastern Wisconsin study, 4 of the 5 farms actually no-tilled corn right into that dead porcine biomass, and we still saw those credits. So there's also some work that's been done with alfalfa corn, first-year corn following alfalfa. Tillage may or may not affect the amount of nitrogen you actually get from that previous alfalfa stand. A spoiler alert or a teaser, stay tuned over the next few years. Dr. Natasha Rayne and others will be doing some exploration here in Wisconsin on that specific topic. So take the credits. That's the whole point here. These cover crops can give you substantial amounts of nitrogen. So take that base MRTN nitrogen recommendation and then subtract off these legume green manure credits. Okay. Biggest thing too is just set yourself up for success. So early establishment, target these small grain or processing crop rotations. There may be some inter or overseeding opportunities to get these clovers established in non-small grain crops. Of course, frost seeding red clover into wheat works really well. So really just be pushing the envelope to get seed in the ground as early as you can, because it's all about biomass. Pick species and varieties that are tried and true in your region. Make sure your drill is calibrated and that it's working, it's putting the seed where you want it, how much seed you want going out there. Do all the right things to set yourself up. And again, site selection appears to be important. So let's not spend money on more expensive, clover cover crops, legume cover crops, and put them in soil types and soil conditions that may or may not be conducive to prolific biomass production. All right. I'll just give a quick shameless plug for on-farm research. There's a lot of folks at UW Extension that would love to help you. Think of a study like the ones that we've talked about today. If you're curious and you want to explore what these credits are on your ground, lots of folks would be willing to help you think through that. And that leads me to just bring up through the NOPP program that DATCAP facilitates in conjunction with UW. There are 10 farms across the state of Wisconsin currently doing large plot studies, corn following different legume cover crop mixes, looking to document nitrogen credits across the state. So a really cool project with lots of folks involved in that. So again, just to screen grab, if you want these in your back pocket here, we're adding Berseed clover to our guidelines moving forward. That less than 6 inch of growth it'll also be 40 pounds. So they're kind of all right in that same 40-pound range, with a 40 to 60-pound range if you get a better stand. Obviously, if you just get a knockout stand, a ton of biomass out there, it's potentially even higher than that 60 pounds. So with that, I'll kind of just stop here and let our wranglers get the rest of these resources posted in the chat. We've got Cover Crops 101. That's just a great resource that has lots of different cover crop species, planting dates, seeding rates after different major agronomic crops. It's just a great starting resource for folks that are interested. Just all sorts of other general resources here that'll be in the chat for you to go back and dive more into this information. So with that, thank you for your time. And if there's any questions, I'm happy to take them.